Hey everybody, this is Tech Teach. Today we're going to look at classes or classifications of levers. There are three classes of levers that you need to be familiar with in this class. We'll be using each classification and trying to calculate forces or distances and mechanical advantage of the different kinds of levers in this class. So to get started, here's a good example of a lever in action. It's a teeter-totter. We're all familiar with this and we've all had a lot of fun on them. If you notice, this teeter-totter has a pivot point in the middle. That rod right there that's going through the middle of the log is the pivot point. We call that the fulcrum. Now notice also that there are two little girls on this side of the teeter-totter and there's one little girl on this side of the teeter-totter. And what's this little girl having to do? She's having to help this girl go up, and I think it's because the weights are out of proportion. If we look at it in physics terms here, you can see that a class 1 fulcrum has class 1 lever has the fulcrum in the middle, but it has two forces. It has a force of effort and a force of resistance, or what we call the load, on the levers. Now a class 1 lever doesn't always have, like a teeter-totter, the fulcrum in the center. It could be anywhere along the lever line between the two forces. A class 1 lever also has the two forces, the force of effort and the force of resistance, going in the same direction. If they're going in opposite directions, the machine would want to just spin around in a circle. So we need to be aware of that when we're working with class 1 levers. A class 2 lever looks a little different. Let me go up. Get my example. Here's an example of a class 2 lever. A class 2 lever, like a wheelbarrow, would have the fulcrum right here in the middle of the wheel. Would also have a load or a force of resistance that's in the wheelbarrow basket. And the effort force would be the amount of the force it would take for you to lift the handles of the wheelbarrow. So in this case, the force would be, the distance force would be the distance between the fulcrum, and the distance of resistance would be wherever the middle of the weight is for the basket. And the force of effort would be the distance from the fulcrum all the way out to the handle. And so you'd have to do some calculations with that. Let's look at it real quick in physics terms. In physics terms, like we said before, here's the fulcrum. The distance from the fulcrum to the load is the force of resistance. The distance from the fulcrum out to the handle is the force of effort. And so we would put that into an equation. We'll learn that in the next set of tutorials. So that's a class 2 lever. Now a class 3 lever is a little different. In this case, we have a pair of tweezers. And the tweezers, whoops, didn't mean to do that. Close that. The tweezers have a little spring on the end. That would be where the fulcrum is. Where your fingers would go and push in on the tweezers, that's where the effort force would be. And then in order to be able to pick something up with the tweezers, you would have to have a certain amount of pressure or force that's put on the ends of the tweezers. So to look at it again in physics terms, let's look down here. The fulcrum is at one end. The effort is in the center, going, in this case, up and down. And the load is at the very end of the tool. So you don't want to get confused between the class 2. See, class 2 has the load, the resistance force in the middle, and the effort force at the end, and the fulcrum at the other end. And a class 3 has the effort force in the center and the load at the other end. Don't forget, you're measuring from the fulcrum to the effort force, from the fulcrum to the force of resistance to do your calculations. So in the next tutorials, you're going to be learning how to take these and put some measurements and forces on it and